So I hope the recording will start. Okay, it has started. Thank you. So yes, so every program has these four sections. I'll repeat what they're used for so that it gets saved in the recording. The code section is used to store instructions of your program. Okay. The data section is used to store your global data, your literals, and your static variables. Okay. The stack section is used for your local variables. So when a function is called, its variables are allocated on a stack. They exist during the execution of the function, and once the execution of the function finishes, the local variables are destroyed. Okay? And in our particular example, we have created a local variable, but we want to use it after the function has finished. So it is not like working for us to return the address of the variable and use it after the function has finished, because using this address, when we access that variable has already been destroyed. Okay, so this is crashing our program. Therefore, we want to allocate our variable, or at least store the values of that variable at some place which can exist after the function execution has finished, so that we can access those values after the function. Okay. So we just discussed that we can't store such values in code section because code section is only for instructions. We can't store such values in data section because data section is only for globals, literals, and static variables. Globals and static variables are a workaround, but they are a bad workaround because they, once allocated, they continue to exist until the end of the program. Okay. What we want is that we just want to our values to exist after the function for some time, so that we can use them, and once we have used them, we want to be able to destroy those variables. Okay, so global variables and static variables, they don't permit us this destruction facility, so we can't use them, store them in data section. So the only section that has left for us is that heap section. Okay. So heap, we were saying that heap is again a portion of memory that is allocated to every program that is running. Okay. So every running program has its own heap. Okay. So heap, how does, what is in the heap section by default? Okay, by default there is nothing in the heap section or garbage values. Okay. So heap section is for you guys, that you, if you need some memory temporarily during your program for some time, then you can request it from the heap section. You can put values in that memory. You can use those values anytime that you want. And once you have finished using those values, you can destroy those values. Okay, or you can give the memory back to the heap. Okay. So consider heap as a pool of memory. You request your program requests some memory from the heap. Heap reserves that memory for you and returns you a pointer or an address to that memory. Using that address or pointer, you can use that memory in whatever way you want. And once you have finished using that memory, you can then give that memory back to heap. Okay, and heap can include that memory back in its free memory. Okay, so as your program requests different kinds of memory from the heap, internally heap will keep track of which portions of the heap are allocated and which portion of the heap are still free. Okay. So initially all the heap is free. When your program requests, let's say, 100 bytes from the heap, then heap will mark those 100 bytes as allocated and the rest of the heap is still free. So the next time your program requests another memory, then heap will not allocate from those 100 bytes that is allocated, but rather search in the free part of the heap the memory that you are requesting and allocate it from that free part. Let's say next time you requested 1000 bytes. So from that free part, it will allocate 1000 bytes and return a pointer to you. Okay, so that this way internally heap is keeping track of which portion of the heap are allocated to the program and which portions are still free. Okay. So once you have got the memory allocated for you using the pointer returned by heap, you can basically access that memory anytime you want. Okay, and that memory will continue to be allocated to your program until your program explicitly says that now I don't need this memory. You can go ahead and free this memory. And then what heap will do, it will take that allocated memory and mark it free or unallocated, and that can be used in future calls to heap. Okay, is it clear the concept of heap? Heap is just a pool of memory from which you can request uh, any memory, any size of memory that you want. So heap will allocate it for you, and heap will return you a pointer to the starting address of that memory. So using that pointer, you can use that memory in any way you want at any time you want. Okay. So heap memory does not gets allocated and destroyed with function calls. Heap memory gets allocated when you request, your program request is to allocate memory, and heap memory gets deallocated or freed when your program explicitly says that now I don't need this memory, so you can take it back. So heap will take that memory back for you. Okay, is it clear the concept of heap? Okay, so we'll see next how we can allocate memory on heap and how we can use it. But just for information, heap, since this allocation and deallocation happens at runtime, and you can basically specify any size to the heap when you allocate this memory, then this type of memory allocation on the heap is called dynamic memory allocation. Okay, this type of memory allocation is dynamic memory allocation because you do it at runtime and you do it at will. You can allocate any memory at heap at any point in your program of any size. You don't need to know the size of the memory at compile time. Okay, remember at arrays we had said that the C++ standard requires you to know the size of the array at compile time. Okay, with heap you don't have this limitation. Dynamic memory, you don't need to know the size that you want to allocate at compile time. Okay, you can know the size at runtime. Let's say during the running of the program, you get it from the user how many bytes you want to allocate, and then you can request heap to allocate that many bytes for you. Okay, so this is called dynamic memory allocation, and compared to that, the memory that is allocated on the stack, we can call it static or automatic memory allocation. Okay, because uh, for memory allocation on stack, we need to know the size of the memory to be allocated at compile time. Okay, so that's why for arrays you need to know the size of the array at compile time. Okay, so memory allocation on heap is called dynamic memory allocation. Okay, it's slightly different from the memory allocated on a stack in a couple of ways. First of all, as the definition says, the memory allocated on stack is allocated on a stack, and dynamic memory is allocated on heap. Okay, so these two different sections are used in these two different memory allocations. Secondly, the allocation and deallocation of the memory allocated on the stack is managed for you automatically. Okay, so the compiler decides or writes code for when does it has to allocate memory on the stack and when does it has to destroy the memory on the stack. You don't have to worry about it. It happens automatically for you when a function is called and when a function finishes execution. Okay, so stack allocation deallocation is automatic. What is not an automatic is this dynamic memory allocation. Okay, because in dynamic memory allocation, you explicitly have to ask, or your program explicitly have to ask the heap to reserve or allocate memory for you. And similarly, once you have asked or requested heap to reserve memory for you, it is your duty that you, before the program ends, you free that memory. Okay, you have to do it explicitly. If you don't do it, it will not happen automatically for you. Okay, so the ideal case is you allocate memory on the RAM, you allocate memory on the heap, and it will be allocated for as long as you need it. Okay, so as long as you need it, you keep it allocated, you use it in any way you want, and once you are sure that you have finished the use, you should deallocate this memory, or you should free this memory, you should give this memory back to the heap before your program ends. Okay, so with this preamble, we will go ahead and see how we can allocate memory on the heap. So I'll unshare this screen and share code. No, why is it? Okay. Okay. So C++ basically gives you two operators to allocate memory on the heap. So before this, I present you the two operators. We'll see how we can solve this problem by allocating memory on the heap. So our problem is that this array A, it gets destroyed by the time we try to access it. So a solution can be that we declare an array, let's say of the same size, on the heap, and we copy all these values to that array on the heap, and in this function, returning the address of this local variable, instead of returning the address of this local variable, we return the address of the array on the heap. Okay, so if we return the address of the array on the heap, then here in X we will receive not the address of the local variable but the address of the array on the heap. Okay, so the local variable will be destroyed, but the array on the heap, it will continue to exist even after the function has finished, because as we just said, the array or memory allocated on the heap, it continues to exist as long as we do not explicitly deallocate or free it in a program. Okay, so here we receive the address of the memory allocated on the heap, and using this address we can access the data that has been stored in the array allocated on the heap. Okay, it's that simple. And then once we have used it, we can deallocate the memory on the heap. Okay, so is it clear the solution to our problem? Is it clear how we are solving this problem of the the local variable that is being destroyed before we can access it? We'll make a copy of it on the heap, and after the function, instead of accessing that local variable, we'll be accessing the memory on the heap, which will store our useful values. Since we need full control over the data of file handling, are these done in the don't bring file handling into it. We'll discuss file handling at some time. Okay, but for the moment, don't bring file handling into this discussion. So, okay, so if this is clear, then let us see how we can allocate memory on a heap and how we can use it. So C++ basically gives you two operators to allocate memory on the heap. One of the operator which is used to allocate and deallocate. New, the operator is called new. It is used to allocate memory on heap. So it will allocate a memory and it returns a pointer. It will allocate a memory on the heap and it will give you back the starting address or the pointer to the memory that it has just allocated on the heap. So this is for allocation, and once you have allocated the memory, you will use it, and once you have finished using it, you want to deallocate this memory. So for deallocation, we have this delete operator. Deallocation, or it's sometimes called also freeing the memory. It basically takes a pointer. It's an operator that takes a pointer. Okay. So let us see how we can use it. So we have this array and we want to allocate a memory of the same size on the heap. Okay. So since we are going to use the operator new, and new returns us a pointer. Okay, so we need a variable to store that pointer that new will return us. So here I will say, let's say it will be a pointer to an p is equal to, now the syntax of the new is new space, and here we give the size of the memory that we want to be allocated on the heap. The size, it can be given as a type or a series of types, an array of type. So here we need to store 3 integers. Okay, so here I'll see 3. Okay, so this is the syntax of the new operator on line number 8. To the right of the assignment operator, we write the operator new and then the size of the memory that we want to be allocated. Okay. So here we say that we need a memory for 3 integers. Okay. So new, what it will do is it will request the heap to allocate the memory for 3 integers for you guys. So memory will be allocated for the 3 integers. Memory size will be equal to the size of 3 integers, and this after completing this new pointer operator, it will return the address of the memory that has been allocated on the heap. Okay. So that address is a pointer. So we will receive and store this address in this pointer p. Okay. So once we have allocated this memory has been allocated, and using this pointer, what we can do is we can basically copy this. Let's see, copy each element of the array onto heap where it will be stored for us, and then instead of returning this instead of returning the address of this local variable, now that we have copied all the data we needed to the heap, we will return the address of the array that we have allocated on the heap. Okay, so we will return p. So once we return p, here on line number 18, x will receive the value of p, which is the starting address of the array on the heap. Okay. Now on line number 18, when f1 finishes execution, a will be destroyed, but nothing will happen to p or the memory pointed to by p, because that memory is allocated on the heap and it will continue to exist as long as we do not delete it or free it. Okay. So here we'll basically use this value of x to print all the elements, but this time from the heap, and once we have used this memory on the heap, we don't need it now, we'll have to free it. Okay. So For free, the operator is delete. Again, the syntax is, and since it's an array, so to delete an array, the syntax is like this. Okay, we give it the pointer, the memory that we want to free, and to tell the heap that this was an array, we use these two square brackets before the pointer. Before the pointer, we put these two square brackets. So this is how allocation and deallocation on the heap works. So we'll just run it to see that this indeed works and does not crash our program. So, oops, line number 24, P was not declared. P, okay, so we don't delete P, but we delete X because the address of the P has now been stored in X and not in P. Okay, P was a local variable here. P was a local variable which gets destroyed when the function is finished. But return basically copied the value of P into X. Okay, so delete, we give it the value of P which is now stored in X. So let us compile it again. Yep, this time it works. We run and voila. We have our variable values that were allocated locally, but we can access them even after the function is finished because in the function we had copied them on the heap, and then we used basically that heap or read values from the heap and did not need to access the local variables. Okay, so this is how allocation and deallocation on the heap works. And if you guys have any questions, data type and their number. Yes, so you basically give them, if you want a single data type, then you just write the type. Okay, it will allocate the memory of the size of that type. But if you want an array of data types, then you write data type and in square brackets their number. Okay, please repeat the syntax of new. Okay, so syntax of new, again, as Usman Tahir said, let us see like this. We'll write F2. So F2, let us say we are just returning the address of one integer. Int I is equal to 55. And we want to return its address, but since it's a local variable, we can't return its address. So we allocate an integer on the heap and copy this value to the integer on the heap. So we say int style p is equal to new int. Okay, so this time we are allocating only one integer. So we don't need to the square brackets to write the number of the integers, because this time we need only one integer. If you need only one type or the size of one type, then you just write the type. So once this is there, then we can copy in P the value of I and return P. Okay. So here regarding the syntax of new, so you write new space and then how much memory you want from the heap. If you want the memory size of one type only, then you just write the name of a type. But if you want memory for an array of type, of certain type, then you write it like this: type, and in square brackets you write the number of elements that you want. Okay, so this is all about the syntax of new that you would like to know. And remember that new will return an address in both cases. It will allocate the memory and it will return the starting address of that memory. So you need a pointer to store the address returned by a new, because later you would need it. So here we store in P the address of the memory, which is the size of 3 integers. Okay. And here on line number 17, since we needed only one integer, the memory size of one integer, so we did not write square brackets and the number. We just write the type. So it will allocate the memory the size of an int. Okay. But in this case also, it will allocate the memory and it will return us the starting address of that memory, a pointer to that memory, okay, which again we will store in P. And then dereferencing those address, we store the value of I and then return P. Okay. And here we can have this F2, and then we can have directly here static. Okay, let's see. Okay, so F2 returned us the pointer to the integer that was allocated on the heap, and dereferencing that address or that pointer, we can access the value of the integer. Okay, that's it. And now again, since F2 also allocated memory on the heap, as I said, anything allocated on the heap is explicitly allocated by us or our program, and it is our responsibility to explicitly deallocate it or free it once we have finished using that memory. Okay, so to free or deallocate the memory of an array, syntax works like this, and if it was a single element, then we don't need these square brackets. Okay, we'll just write it like this: delete x2. Okay, so this is the difference between syntax of new and delete for depending on whether you are allocating a single element or you are allocating an array of elements on the heap. Okay, so we compile and run it again. Okay, so again, to return 55. Okay, so here you, okay, before I move any further, any questions so far? Let me put line numbers. Any questions so far? Are you guys sure? Because these things can get tricky. Can we allocate memory for all? Yes, any kind of data type that you have, you can ask heap to allocate memory for the size of that data type for you guys. Okay, these include all the data types that we have studied so far, like int, float, character, etc., and other data types that we will study next semester. But it works for all data types. Is it necessary to delete? A very good question. Yes, it is necessary to delete, because the rules of the heap work in this way that it is a responsibility of the programmer to manage memory on the heap. Okay, so the programmer requests heap to allocate memory for it, just like we did using new, and therefore it is the programmer's responsibility to deallocate the memory or free the memory that it has requested to allocate on the heap. Okay, so it is a very common error for beginners when they use heap, that they allocate memory on the heap but they forget to free or delete the memory on the heap. Okay. This is an error and it is called a memory leak, like Usman said. Okay. So if in your program you are allocating memory on the heap but you are not freeing memory that you have allocated, then we say that your program has a memory leak. Okay. It is a very common error in C, C++, and it will ultimately it will waste resources. Okay. Just to make clear, once your program finishes execution, when the program is ended, then everything belong to that program is destroyed. Stack, code, data, and including the heap. Okay, so memory ultimately gets deallocated, but it is a bug to have memory leaks in your program, which means that by the time your program ends, there is some memory on the heap that is allocated, but you have not freed it when the program reaches its end. Okay, and its effect is seen especially in longer running programs, because ultimately if you keep allocating memory and do not deallocate memory or do not free memory, then all your RAM, it gets eaten up, because if the memory has been marked as allocated to you, then that memory cannot be used for any other purpose by the program or by the operating system. Okay, so the issue is there are programs that run for long amount of time. If I don't know whether you have heard or not, there are programs called servers, and servers can run for many years. Okay, so if there are uh, memory leaks in your program and you have written a server, then ultimately all your RAM will be eaten up by these memory leaks, and there will be no more RAM available for your program as well as for other programs to run. Okay. So it is a very bad practice to have memory leaks in your program. So always remember that whenever you allocate memory on the heap, it is your responsibility to free or delete that memory when you have finished using it. Okay. So smart pointers, yes, smart pointers we'll study next semester. Okay, so the answer to the question is that yes, it is necessary to delete memory that you have allocated on the heap, but after using it. If you use memory after deleting it, that's again a kind of error. It will crash your program. Okay, you can use that memory before deleting it, but once you have deleted that memory, you can't expect to use it again. If you want to use it again, then you have to reallocate the memory, reinitialize it, and then use it. Okay, is it clear? Yes, Uzair, you want to say something?
Sir, can you explain the question number 2 of the assignment?
We'll come to it after the class. For the moment, please ask questions relevant to the topic that we are studying. Any questions so far about it? So let me, what if we want to store pointer variables in heap? Do we write new int pointer to new int p? No, you want to store one pointer variable or many an array of pointers. Yeah, pointers store addresses, but he's right. You can have a pointer value or an array of pointer values that you want to export outside the function, just like in this case. Then you will have to allocate space for it on the heap. Okay, so I think it should be doable like this. Let me go ahead and try it. So we make it F3. Let's say the address is like this. Okay. And we want to export it via heap, so we basically, I think this should do it. New int pointer, because here we are allocating space for a pointer, and we store the value of the pointer. So here I think, okay, it doesn't matter much, but I think here the type should be pointer to a pointer. You see here we are allocating space for a pointer, integer pointer. Okay, so the address that will be returned will be the address of a memory location that contains an integer pointer. Okay? So the address of a memory location that contains an integer pointer should be a pointer to an integer pointer. Okay, so the pointer to an integer pointer is written as int double star. So the rest is the same. By the way, here also we will be returning a int double star. So if we do it like this, then this should work, I think. And then we delete. Since it's a single type, so we delete it. So let me run it. Error. Invalid conversion end to end pointer permissive. It's line number 23. Line number 23. Okay, so we convert it into integer pointer typecast. Okay. 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 So it worked, but it is displaying the value as hexadecimal number. The same value is being displayed as hexadecimal numbers because pointer values are displayed as hexadecimal numbers by default. We can modify it to, we can also make it hexadecimal to make sure that we are getting the same number. Just to make sure that everything is good. You see, FFFF. So I hope this answers your question, Mohammed Farid. Okay. Similarly, here we have declared only one pointer. You can also declare an array of pointers if you want to need it. Yes, 2D pointers, anything you need, you can allocate memory for that on heap. Well, not 2D pointers, but 2D arrays we had studied before the mid, if you remember. We had studied matrices, how we can uh, store matrices, add matrices. For that, we needed 2D arrays. So we had actually studied 2D arrays in class. What we have not studied is passing 2D arrays to functions, etc. That I would let you discover on your own, because there is a slight uh, complication which you will know if you study or try to pass 2D arrays into a function. Okay, so if that is clear, then there's one thing that I would like to emphasize, that heap is allocates memory dynamically. Okay, so it might arrive that you request memory to be allocated from the heap by using or calling the new operator, and there might be no memory in heap for to be allocated. This can arise for several reasons. There might be like memory leaks in your program, and ultimately all the memory is occupied, allocated. You have never freed any memory, so heap says that there is no memory for you to be allocated. And or another case, you, because of an error or something else, you request for a size that is so big that there is not enough RAM or not enough memory in your computer to be allocated. So in that case, it can arrive with big sizes or small sizes. So in any case, there is a possibility that it might happen. So in that case, memory allocation on heap will fail. Okay, memory allocation on heap will fail, and what will happen to the new operator? What will it return to you guys? If memory allocation on heap fails, what will what do you think new should return? What value should new return? 0. Very good. A null pointer. Okay. If it succeeds, it returns a valid address. Okay. If it fails, then it returns 0, or more appropriately, it returns a null pointer. Okay. So we should always have this possibility in mind, and whenever, oops, okay, I did something to my screen and now it is gone. Let me unshare and reshare this. Okay, give me a minute because I'm not good with these technologies. So full screen, and here. No, you can't leave without seeing what I'm going to tell you. Give me just 5 minutes. So it is very important that whenever you allocate memory with new, it is almost imperative that you should check whether that memory allocation is succeeded or not. Because if new failed, it would return null, and you should check if value returned by uh, new is null, then you should always have print out an error error and exit. Either exit or handle it in any way you want. But in any case, you should be able to detect that memory allocation has failed. Okay, and how do we detect it? We check for the return value of new. So every time you allocate memory on the heap, you should always check whether memory allocation has succeeded or not. Okay, this is very important because let's say your memory allocation here on line number 8, let's say it failed and P new return null. So P will have the value null, and if you don't have this check here in this line 11 12, you will try to use that null pointer. Okay, and I hope you know by now that dereferencing a null pointer will always crash your program. Okay? So it's always better to handle the error yourself than let your program crash. Okay, so always whenever you allocate memory on the heap, before doing anything else, check the return value, the value returned by new, and only if it is not null, only then you should go ahead and proceed with your code. If it is null, you should know that there is an error and you should find some way of handling that error. Okay, is it clear? When you add null plus 1, does it change the value of the pointer? I mean, you do null plus 1 and store the result in another pointer. Is this you want to say, or is it something else? Like, is it like this? Int static p is equal to null plus 1. Is it something this you're talking about? No, the value of null itself will not change. It is defined by the system or the compiler or the C++ standard, but it's a literal. You can treat null as a literal. Okay, so the value of null itself does not change. Just like the value 5, it should always remain 5. It's a literal. Okay, so you can treat null as a literal. Double star, double star means pointer to a pointer. Int star p means p is a pointer to integer. So in p you will store the address of a memory location that stores an integer. Int star p means p is a pointer to integer. So in p, in the second p, you are going to store the address of a memory location that contains the address of another integer. Okay, so it's a pointer to a pointer, address of a pointer, you can say. A normal pointer is the address of a variable, and a pointer to a pointer is the address of another pointer. Yes, if you want, you can go any length you want. You can go. In complex programs, you go to 3 or 4 stars. What is the data type of pointer? The data type of a null is a simple pointer. Okay, and pointers can be converted into each other. I mean, integer pointer can be converted into character pointer can be converted into float pointer, etc. Okay, so the data type of null is a pointer. Which type of pointer it is, I'm not sure. If I have to guess, I will say it is a type of void pointer. Okay, so void pointer is a pointer that does not have any type, but I'm not sure. But in any case, the type of null is definitely a pointer. Which type of pointer it is, that I'm not sure. So null can be assigned to any type of pointer. I think it will be void pointer. It will be void pointer, the type of null. Any other question? No? Okay, so if you guys don't have any question, then what we can do is that I can stop the recording of this session as a class, and if anybody has any question regarding the assignment, they can continue to stay and ask questions about the assignment. Okay.